Good afternoon, everyone. Welcome back. May I request everyone to kindly be seated for the keynote address, please. Before the commencement of the program, I would like to make an important announcement pertaining to safety. In case of any untoward incident like fire evacuation is required, you are required to exit from this hall through the fire exit gates nearest to you without any panic. There are 4 exit gates from this hall, 2 on the left and 2 exits on the right. In case of fire, the fire marshals will position in the aisle and exit gates to help you evacuate. May I now request Director General of TERI, Dr. Ajay Mathur, and our keynote speaker, Scientia Professor Deo Prasad, Director of CRC Low Carbon Living, University of New South Wales, to join us on the dais for the keynote address, please. And I would like to request you to please welcome them with a round of applause. I would now request Dr. Mathur to kindly introduce our keynote speaker and take this session forward. Thank you.
Colleagues, it's a pleasure to welcome you all back here. I know coming back after lunch is a little bit of a challenge. Professor Deo Prasad was mentioning maybe it need not have been too attractive a lunch that would have got people back in sooner. But I'm sure people will keep on coming in as the session goes on. It's such a pleasure for us to welcome Professor Deo Prasad, who is the Scientia Professor at the University of New South Wales. He is, for people in the audience, I don't think there's very much introduction needed about his being an international authority and a leading advocate for sustainable buildings. Sustainable buildings are important today, they're even more important tomorrow. And the kind of advocacy that Professor Deo Prasad has done through his work, through his outreach, and through engagement with the policy process has helped us all in seeing how the sustainable building idea is carried out beyond the narrow confines of our research computers. He has been honored for all his work, and as you would note, the placard in front of him says Deo Prasad AO, the Order of Australia, which is a recognition which the Governor-General of Australia bestows on citizens for their most honorable contributions, and in his case for the services to sustainability and renewable energy through his research and for the extensive international community work. Professor Deo Prasad, sustainable buildings is something that all of us believe are essential for the future.
Absolutely.
We look forward to hear your thoughts on the issue.
Okay, thank you. How do you take this back? One-sided arrow. Yeah. Okay. Thank you very much. Thank you for inviting me, and it's really great being here. I've been here a number of times to TERI. I've spoken in the building next door over the last 15 years, probably 4 or 5 times at TERI lectures and so forth. So it's good to be back again. The topic of the GRIHA conference, Fostering Partnerships for Sustainable Habitat, is very relevant in terms of what I do. I run a body which is called a Cooperative Research Center for Low Carbon Living, and it is based on collaborations in the Federal Government of Australia, funding rounds, there is provision for industry, government, and research coming together to actually shape the agenda within a sector. So in this case, the built environment as a sector, the three groups, industry, government, and research, put significant amounts of money, all of them, so that they have a share in what comes out at the other end. And that makes them committed to making sure that what gets done is relevant and that the success is measured by the impact of what we do. In other words, who's using the products, technologies, tools, and not just publications, academic publications. So it's very relevant in terms of how a collaboration on a national scale, which is the body I lead, can actually deliver outcomes for industry. So buildings and built environment, as you know, the situation is not very different in other countries and in India as well, where the sector does not necessarily put too much money into research innovation. They do draw innovation from places, but they're not actively engaged. So even if there is a champion within an organization trying to push some of these things, there is not deeper engagement, deeper penetration within organizations who are actually committed to delivery of sustainable outcomes. So in Australia, this particular research group is what's responsible for making that deeper engagement so that you can actually drive sustainability agenda even further. How we did that, the industry and government came together and we figured out a structure at the building scale, which is looking at new technologies, new tools, new ways of integration, and good ways of measuring outcomes in terms of zero carbon buildings and beyond. So we do technology research, we do social research, and I'll come to all of that in a minute, but it's more holistic and system-wide in nature. The second program of works within the center is about precincts. In other words, a large development at a time. How do you get those right? Because they go beyond just the sum of buildings into landscapes and transport and how a whole range of other urban impacts can be assessed. And the third one, of course, is people. Unless people are part of the journey, it is going to be very difficult to deliver sustainable outcomes. You can design a 10-star building, and if you put 2-star people inside the buildings, as they say, you'll get a 3-star outcome and not the 10-star capability that you have allowed for by designing a 10-star building. So how do we better understand community aspirations? How do you better understand what makes them tick, or what makes them really get involved in making the outcome and outcomes better from a building use point of view? How do we understand consumer and market insights better? In other words, what makes them buy renewable energy, photovoltaics on rooftops? What makes them get batteries? Are they just doing it because there is a subsidy, or are they more deeply involved? Trying to better understand the community side is what that program is about. So as a collective then, we were able to, over the last 6 years already, have a look at how we can not only look at buildings at a time, but urban scale and community scale problems together in a more holistic way. There are different groups of end users in all countries, the governments, the manufacturing sector, which needs to be engaged because ultimately you want to deliver products that can be commercialized, and the development sector, which builds things, and the professional sector, the consulting groups, who need to be upskilled so that they can better deal with the types of problems we're looking at. They can better understand issues of the interconnectedness of the different issues in delivering high performance buildings. We normally have the big end of town in Australia, as they say, big end of town, big companies can invest in research, but the small and medium companies miss out on that. So we started a whole network so that they can be involved. In Australia, actually, most of the activity within the building sector is run by small and medium enterprises, the small companies, 1, 2 people at a time, trades and all, and so forth, who need to be upskilled because you cannot just have the big engineering firms designing things and the community, the vocational community, not up to scale in terms of delivering. So it's as I said, it's a more holistic approach. At the beginning of the center life, we set up some targets for carbon reductions, and within that we looked at 10 megatons of carbon reductions through our work, which is about 12% of the national goal in Australia by 2020. So we have recently done some measurements independently by PricewaterhouseCoopers, and they verified that we are not only we have delivered, but we are way ahead in terms of delivering all the outcomes that we had said, and at the same time delivering economic outcomes for Australia. So in excess of $600 million worth of outcomes for the country from jobs and growth and so forth, while delivering better outcomes from a sustainability point of view. The two need to go hand in hand for a better outcome, because if government puts in money, they want to see a better economic impact and jobs and growth and so far. We also, in the process, delivered a very large number, a once-in-a-generation jump in terms of postgraduate PhD outcomes. More than 90 PhD students came out, all industry ready, so they don't necessarily just end up in academia, but also work in industry in terms of delivering better outcomes. So it's a more holistic look, as I said. So how do we do it? I'll give you some sample. We have done way over 100 projects in the last 6 years already, but the types of projects I will go through briefly in terms of explaining why we decide on a project and how we deliver outcomes that go to impact. This particular project, our university, you probably have heard in the last couple of days, the University of New South Wales is among the very top end of research organizations globally in terms of photovoltaics and renewable energy research. We probably have in the order of 35% of world IP in the building I work in alone. So this is for photovoltaics, and everyone's putting solar panels on the roof, but large numbers of those technologies came out of University of New South Wales, a lot of them through companies in China. A number of those were students of ours who went and started these big companies now operating globally. So that has been happening, but recently in this research, we looked at, okay, so in the future, how will we be using photovoltaics, building integrated photovoltaics, using not only putting panels on roofs, but making roofs the panel, and what else the roof can produce, in other words, heating, cooling for the buildings. So how can you capture the waste heat, put it through certain types of cooling engines like desiccant driven, and at the same time, when you are home, at work, you can get electricity, you can get heating or cooling, whichever one is required. So the roof itself pays itself through savings in dollars, for example. So we looked at a prototype that is under test at the moment, and it's going to be commercializable ready in the near future. So this is just one of the products within the renewable energy sector. So the industry said, okay, let's look at the future of roofing, how we might have much more active way of using the outputs, heating, cooling, electricity, and we developed a product and are in the testing mode already. The other type of project, when you look at PV on roofs everywhere, the energy utility told us that 52% of all photovoltaic panels were underperforming. People think that you stick PV on the roof and it is performing and you get all the credits for it, but not the electrical outputs. So we then took on the challenge of making sure that at least what's put up on the roof delivers what they are designed for. So we have we developed a tool, Solar Analytics, and from our office in north of Sydney, they are looking at about 15,000 roofs now. In about 2 years' time, it will be 25,000 rooftop PVs, they can spot anytime, and then guide the people where there is underperformance, and someone goes and fixes those on a fee-for-service basis. So this tool is now national within Australia, and it's in 3 other countries already. The utilities are beginning to use this to make sure that they actually deliver what output that's been promised in that sense. So this is now looking, it's still at photovoltaics, but making sure that the outputs are consistent with design. I think Alistair, one of my colleagues, mentioned yesterday about the University of New South Wales being 100% photovoltaic energy driven. We did some of the early work within that to look at the barriers in terms of how a large consumer like a university can, after having trialed out efficiency measures, on-site generation, and look at how they can get PV from off-site, far away, hundreds of miles away, using the poles and wires to your site and offsetting all your energy. So we are doing that now, and using different distributors like Origin Energy in our case to be able to do that. So some of the work we did, looking at barriers, it led to the university going all the way in terms of trying to make that happen. We looked at embedded carbon. Concrete is one of the big embedded carbon materials. And there's huge amounts of fly ash, etc., from the electricity production processes that are around. This particular project looked at geopolymer products, which are about 1/3 of carbon emissions compared to concrete, but still has the same level of durability and all other characteristics. And this product is now tested, verified, and we are trialing at a site in south of Sydney on a very long stretch of coastal area. So in the future, as climate changes and there is more and more extreme wind having an impact on the coast, we are trying to use these as bollards that will protect the coast. And if it's past that test, it will become a low carbon way of actually doing that, because we know, according to most scenarios, there is serious forecast for coastal protection needs from extreme winds and so forth. We have other material products. One of our colleagues who's not here, Veena, she took on a couple of our projects and using high temperature to develop new products from things like glass. So most people think that glass to glass recycling is very easy. You melt it down and reform it. It's not the case. There are impurities in glass, the extraction of which makes it very expensive process. So most of the glass is not actually recycled. And she said, well, why do we have to go from glass to glass? Why can't we get another material from that process? So she trialed, and she can get a stone-like product, a designer marble, if you like, type product, using the chemical impurities to give you color and texture as a positive rather than a negative in that sense. So that material is ready, and she's come up with, and she might be here tomorrow and talk about micro factories. How do you take these to rubbish tips, collect the material, recycle, and move on to the next site? We do a lot of work in terms of policy work, supporting government policy, and we have the New South Wales government, which looked at a lot of our work that we were doing and then topped us up with additional funding to provide the evidence for the policies that they were looking at. So when government is looking at policy in an area to do with energy, buildings, and environment, they tell us what they're considering. We collect the evidence and put good science-based information in front of them, and they decide then whether to go via a policy pathway or not. So this is a very much interactive process with government, industry, and research working together towards policy-type outcomes at the same time. Within that, we have done work on what we call basics energy assessment tool. We have a assessment tool that we use to rate buildings. So if you're building a home It's a 3-star, 5-star, whatever star rating you can get. This tool needed post-occupancy evaluation. We have done that on a few hundred houses, and now we are able to feed back the information, so government keeps changing the stringency of the tool based on that. It is not building code led, but it is just an additional measure for that. But on the building code side, we have also looked at how we can develop a technical and business case for much more stringent building codes. We know that tools like we have here in GRIHA is driving best performance, but building codes eliminate worst performance. But if you can use building codes to improve the game so that you can chart out where you are now and what it means to be zero carbon buildings and how the stringency can change over time to deliver zero carbon buildings. So we did a study and put it back to the government on our own, saying that if you have a 10-year horizon and everybody knew what the building code changes are going to be for 10 years at a time, they can innovate, they can invest in new products, new materials, new technologies, and gives them confidence to do that. But at the same time, we will know our pathway to zero carbon buildings because the building code can drive that process, and consultants and others will know that, and there is no choice in the matter because it's compliance based. So we developed the tool, and the government is actually looking at that now with a view that they will adopt a 10-year horizon for building codes at a time. We looked at cities, either precinct scale or urban scale, and looked at a tool that we developed, which is using international standards organization, Scope 1, Scope 2, and Scope 3 methodologies, which means what happens in the city itself, what comes from outside, but also including embedded carbon, not just operational life of the building, but embedded carbon as well. And this tool is freely available of our website, and we can actually benchmark a whole city. We can monitor its performance over time with changes. You can identify which areas you can actually intervene in and assess the impact of the intervention before even undertaking those interventions in a predictive sense. So this tool allows you to monitor, map in a very rigorous way. This is based on international standards organizations, Scope 1, Scope 2, Scope 3 methodologies that is used widely in Europe at the moment. We also look at urban microclimates. So as you know, climate change has implications on urban microclimates, and we on a 43-degree day, our researchers, Matt Santamouris and his team in the Faculty of Built Environment, have been looking at flying drones and measuring whole areas at a time, where on a hot day, you can look at what the temperature of surfaces are, which ones are much worse, the road black tar, brown concrete, types of roofs, within that different types of roofs, which ones are cooler than others, and feed that information back to the planners so that they can actually, through planning decisions, incentivize use of better materials and so forth. So looking at urban climate mitigation at a measurable scale, and this is available. We have done works for Western Sydney, the city of Darwin in a big way, and they are investing very heavily in fixing their problems and so forth. So there's a lot of work going on within that. We know there is a link between health, what we call co-benefits in terms of health through better planning, walkable cities, cyclable cities, and so forth. So what we have done is developed a tool that planners and policymakers can use in terms of assessing or comparing alternatives. So if you have a walkable suburb and looking at to what extent the health improvements can be explained through activity like walking and cycling and so forth, and plow that information so that there is a way of judging on a planner's part as to whether they encourage walkable and cyclable cities through active planning, not just letting it happen, but active planning measures. We have living laboratories around the country, about 16 of them, where we do research with different types of communities, both test bedding technologies and performance measurement from that, but at the same time looking at people side, better understanding health, well-being, livability type factors in actual developments. So in this particular case, in Western Australia, we were involved in helping develop a 100-home development, zero carbon, which we have measured and now verified that they are in the operational life, zero carbon. And in doing so, we looked at other measures like community renewables, community-based storage, and so forth. So what one of our students did, a PhD student working on that project, used the blockchain approach to look at what we call peer-to-peer trading. So all the 100 homes had solar, PV, and battery, and people can actually buy from each other storage when they run out of their own. So by doing that, they found that within a community that size, that there are always people who are not home. So their PV, their storage could be a supply for somebody else. So at the end of the day, when you have run out of all storage and cannot trade with each other, then you always have the option of going back to the utility, the grid, and buying it off that. But you do that only 5 to 10% of the time. The rest of the time, you just share with each other. There is a ledger, and end of the year, you know who's bought how many electrons from whom. So this is now a major company. This won this year's World Innovation, a Disruption Award given by the owner of the Virgin Airlines, Richard Branson. And as a result, this is now in 5 different countries. They are beginning to use this as a peer-to-peer trading platform in the blockchain domain. And it's, I believe one of the utilities in India is also using this now for similar type of purpose. So that's the actual commercialized outcomes, and the company is now employing about 15 engineers already trying to further develop and enhance the tools capabilities. We thought that schools are a good vehicle for not only learning what to do in terms of energy savings and so forth, but be a good vehicle for taking knowledge to their homes and do energy audits, simple level audits, but engage the family and community in terms of doing better things. So one of our projects looked at that and quite successfully engaged many schools, about 15 schools in Western Australia, and this has now gone national. Schools are beginning to buy into this so that they run schools programs. Students have the learning capability, but they also go home and do their own homes and so forth. So that's another project. When governments develop policy and focus on a particular way as to say, okay, we will subsidize high-rise commercial buildings for energy audits or whatever, they're doing it quite often without evidence. They think that might be a good idea, and someone does back-of-the-envelope calculations. What we did, looked at last 30 years of data from the federal government and state governments in Australia, and using agent-based modeling, we looked at not only the hard savings from change of technology, but where people and their engagements were concerned, both hard and soft factors, in terms of better determining what would be the best impact for that subsidy dollar in terms of targeting the policies. So we have given governments an option to actually stress test their policy before they implement it, as to where the biggest bang for the buck will come from. And this is now widely available, and a lot of consultants are beginning to use this with governments in different areas. And it can be used in all sorts of policies in looking at where the biggest carbon reductions might come, what type of interventions in policy might deliver for the same number of dollars of government money, the best outcomes in terms of carbon reductions and so forth. We also have developed a tool which might be talked about later in the session, which is what we call triple bottom line value proposition discussion between a developer, a client, an architect, and so forth. Traditionally, it's a lot is on cost, as they say. So what we did, we created a lot of evidence linking better indoor environment in greener buildings, like the type that GRIHA tries to encourage through its own systems, trying to look at better indoor air quality, the well-being and health of occupants in the building, their performance and productivity, and tying those things back into a bigger value proposition question, whereby even if the cost of the building might be higher, in 5 years, if the payback's much better for client like government and universities and so forth, then you can see the logic why they should maybe pay 5% more, but they will have paid that off in a couple of years and are way ahead for the rest of the life of the building. So that is a good conversation platform between those people. What we also looked at is a knowledge platform. When you go to a medical doctor, describe your problem, they type away, and what they're doing is looking at a platform called Cochrane Collaboration, where they have the latest medical evidence from the top journals and research institutions that talk about that particular problem, and given what might be the best advice on a particular question. So doctors always look at that and advise you on what the treatment might be, or how you should actually deal with the problem. In the built environment area, there is not a platform. For good reasons, I guess. There's not much very solid research. We don't look at hundreds of houses being studied at once on a particular problem with thousands of people involved, whereas in medicine they do that, very well sampled, controlled sampling studies and so forth. So what we look at is evaluate research according to their quality and good science that underpins that, and we want to put that on a platform so that people can actually assess for themselves, the policymakers or practitioners, as to what is the best value option from the knowledge that we already have globally. And it may also have information locally on those sorts of things as well. So there's a lot of research we do. We publish a lot of guidelines. We publish a lot of catalogs with brief, succinct bits of systematically reviewed information. We have fact sheets on certain topics. We run national forums and engage communities, run roadshows on certain topics, just to make sure that the community is part of this journey towards low carbon. We have worked with a number of universities and CSIRO around Australia to see how best we can develop national research capability where they can collaborate to deliver better outcomes. And even beyond Australia, we have looked at working in China with United Nations funding to develop guidelines for sustainable cities and communities and so forth, which is already being used in China. This particular guideline is being used by 5 cities, and when they talk about 5 cities, they are pretty big, with tens of millions of people in each city. So they make that a requirement, if you like, for development, that they go through that particular process, then it's reaching out to a very large audience. So we continue that. The work that we are doing now is finishing middle of next year. We are already in plans for another year, a collaborative exercise of a massive scale, which is called Future Cities, looking at smart, resilient, sustainable, and healthy cities of the future in a more holistic, system-wide way, to see how industry and government can come together with research to deliver outcomes that actually improve, to get better idea of all these things that we have been talking about since yesterday. What is smart city, what it means, how to measure, and how do you engage, what do you do with the data, how can data be usefully deployed to make decisions and create evidence for policy and practice, and in doing so, better understand community engagement and community capability in terms of co-design and planning decisions that you can make that is better for the cities of the future. So thank you.
It was a pleasure to hear Professor Deo Prasad. Both, it brings together the science, the analysis, the outreach both in getting data and in presenting it in a manner that's useful to various kinds of stakeholders. We do have time for some interaction, and if there are any questions, could you let me know by a show of hands? That will help me manage the time. Okay, I see two hands. Professor Kabre.
Sir, it was a wonderful.
Professor Kabre, could you also introduce yourself?
I am Professor Dr. Chitrarekha Kabre, and I'm working at university in Haryana, and I have my PhD from Australia. So I had interacted with Professor Deo Prasad yesterday. It was a very extensive presentation, the kind of extensive research work you are doing, and I'm just interested in this RP 3020. You have said that climate clever school. So if you can just elaborate on this, what exactly meant by clever schools? Is it the user who is participative in this? Are they intelligent, or the building is intelligent?
So it's a combination. The project is trying to involve teachers, students, and the community, the school community, parents and teachers and so forth, in trying to not only lower the carbon footprint of the school itself, and they set up competitions within class and groups, and they do assignments. So there's a whole lot of learning involved in there. And at the same time, they take resources like tools and so forth that we develop, and do trial and test it at home, and tell their parents how they can save money by reducing energy bills and water bills and so forth. So Climate Clever is a combination of all of those things, not just that the people are becoming cleverer, in other words, by doing the right things, but also the building gets a lot of attention, including some of the smarts, the technologies and so forth.
Actually, I just recall there is a school called Willow School in USA. That is also based on some such participatory principle and futuristic and regenerative principles, where users also are actively participating in making the school responsive to the climate change and carbon emission, etc.
Yeah.
Yeah. Yeah. Good afternoon, sir. Myself is Jatinder Kaur. I'm faculty in architecture, teaching architecture since last 22 years in a government college. So my question to you, sir, is, what are the validation methodologies you generally follow in the simulation processes, in the development of the various tools that you have discussed? Validation. So how do you validate the simulations?
Okay. So the particular one that I mentioned, Basics as a tool, is a government planning requirement, if you like. You assess homes for a star rating and so forth. The validation methodology we use here, and one of the researchers is here, he might talk about it in his paper later, but is actual data. So if you said this house is going to be 5-star, and that corresponds to a particular energy usage as predicted. When you move in, and after a few years of data, if we find that it is not so, it's much lower, then there could be that the tool was not doing the right thing. It could be that the building, the way it was built, because predictive tool is based on a specification for a building and not the built building, that it may have insulation that's fallen apart, or there are openings through which air exchanges and you lose the heat and so forth. So building defaults could be responsible. It could be the user, because the user might not be using it based on the assumptions made about how the building should be used, opening doors, windows, when they happen and so forth. So the project looked at a number of those factors, trying to survey users, trying to do deep diagnostics using infrared cameras to look at what's inside the wall, whether the insulation has sagged so far, which actually happens quite a bit, and so forth, and then advises government on how best to improve that. So that may lead to a new way of tying insulation up so that it does not sag, for example, and a level of inspection for the building after it's built, so that there are not many openings and between the cornice and skirtings and so forth, or between doors and walls and so forth, that allows heat to escape. So it allows from that data being collected, both soft data by interviewing people and hard data by actually monitoring the energy to inform the tool improvement, and they go and improve it, and it helps the policy deliver better outcomes.
Thank you so much, sir.
Yes, please.
Thank you. My name is Ghanshyam Pal. I'm an associate professor of civil engineering at Shivnadar University. So my question is, like you said, application of say geopolymer concrete in buildings. So that is one way of sustainable approach, one approach to the sustainability. But again, once you have built that building, the thermal comfort of the occupant is not guaranteed with that new approach, new material. I basically focus on thermal comfort and the built environment. So is there a material aspect through which we can address this continued thermal comfort? With that, I personally focus on how I can improve the thermal comfort in affordable housing, because there is no air conditioning, and we all know, improved thermal comfort leads to the highly productive societies. So with that, and I'm trying to address this from the material. So I'm a structural designer as well as a materials engineer. So structural design wise, I have seen people approaching, window to wall ratio, no more glass building, and so on and so forth. But from material point of view, which is more basic approach, what is your take on that?
So your question is, what kinds of materials can lead to better thermal comfort?
Yes. Is there any new approach? Because basically, I'm trying to develop a system with the PCMs and all, which is one of the work I'm focusing. Your take on that?
Okay, no.
Thank you.
So the project that I talked about in geopolymer was simply addressing the embedded carbon. So it's trying to reduce for the same type of material you would otherwise use, like concrete, that this product is 1/3 of the carbon embedded in the product. So that's a problem that it's trying to tackle. In terms of your main question on delivering comfort and well-being of the occupants, which is the ultimate goal of a home or any building, that it delivers better outcomes for people. Clearly, you can use different combinations of materials, and comfort prediction is quite possible these days using all sorts of tools, simulation or otherwise. So you can use geopolymer where you used concrete or brick, and use the thermal capacity of the material in the right way, which provides what they call capacitive insulation, but at the same time you may need other insulation. But on the very affordable end, maybe some of those things are less affordable. But when you're using product like geopolymer, which could be cheaper because it comes from a waste product, it has the same thermal characteristics as concrete, I think the opportunity is better that it can deliver the same comfort levels for cheaper materials. So that was the reason behind that product. But on the thermal comfort issue, there's a whole body of research there, depending on what type of design, what climates you are looking at, how severe the climate is, and so forth. You can design homes that are quite comfortable now. There is a lot of information and data available. I have done a project about 15 years ago in Himachal Pradesh with the Himachal Pradesh government on Australian aid. We built 25 homes under one of those affordable housing schemes. I think it was called Gandhi Yojana or something like that. And we had those 25 houses built in very cold climate. The idea was that people don't use trees up the slopes of the mountains, chop it down and use it for firewood, because they were holding up the soil so that there is no subsidence happening. So we proved through monitoring over a year that through very simple design measures using either bricks and blocks and so forth to deliver a lot more comfortable homes in those types of slightly extreme climate even. So it is possible to deliver even in the affordable homes, which is less money involved, I guess.
Okay. Yes. One more.
sir.
Okay. And these two will be the last. Yes,
sir.
please.
Myself, Kushal Matai. I'm from School of Planning and Architecture, New Delhi. I'm working as a research scholar over there. So my core area is solar photovoltaics and its application and its effect on urban heat island. So I'm trying to identify that. But here I want to ask a question that you expressed that you have worked on, 2-3 projects you've mentioned about. One was specifically about the BIPV. So I want to know how are you addressing the temperature levels, the ranges in the temperature in terms of when we are going for the BIPV. Or are there any, because you also mentioned that we are trying to evaluate that whether what kind of, generation expansions we are able to do. Because as of now in India, we are talking about first generation solar cells only. We are relying mostly on that. So when we move to the third generation till that point, like perovskites or polymer based, so are there any, research projects or, is that kind of, domain which you are trying to cover up in your research, any research? That I would like to know if there is any possibility.
So this is looking at...
This is looking at PV on buildings
Yeah.
and the impact of PV technologies.
Yeah,
on-
in terms of urban microclimate.
Absolutely.
Yes, so photovoltaics, uses sun falling on the panels. A large part of it is converted to electricity, and it shades your roof below. So those things the
Yeah.
fact that it reduces cooling load potential for the buildings and so forth, and there is waste heat, and that waste heat can be harnessed itself.
Sir, if I may interrupt, what I was trying to ask was that there is certain standard temperature, 25 degrees Celsius, that is the operating temperature for a solar photovoltaic panel, standard. So when it reaches higher, ambient temperature goes higher than that, is there any, possible solution which you have achieved to as of now? Because you were saying in 2-3 projects you mentioned about that you are trying to increase the efficiency of the solar photovoltaic panels.
Yeah.
So how are you addressing that? That's what I want to know.
Okay, so yeah. So when the temperature of the panel goes, largely, I think my colleague standing right up there on top is the photovoltaics guru in my team. When it goes past 50 degrees, the efficiency curve starts to dip down, and the panel becomes less efficient. Yeah, so the efficiency starts going down. But what we are doing in that BIPV project, we are, by capturing the waste heat, we are making sure that the temperature doesn't go that far up anyway. And then we deploy that waste heat for better purpose.
So the key issue is it's BIPV. So because it's BIPV, you've got at least one side which is more amenable to temperature control. And that's how you manage it. Okay, last question.
Namaste, sir. My name is Siddharth Samaya. I am a real estate developer in Madhya Pradesh. Sir, you talked about blockchain method. You are partnering with utilities. You have already partnered with 5 utilities. So do you have any plan? Because I consider that technology significant throw. So do you have any plan to partner with developers in future? Because a developer can use that technology in his society,
Absolutely.
in his community.
Developers are already looking at that because when you're developing, say, 100 homes or 200 homes, that's clearly a part of the benefits that if you are providing solar storage, a blockchain platform, so that they don't even have to go to the grid most of the time, they can reliably share because these are pretty well developed. So this is one of the big disruptors in how cities might power themselves and how they might share within an urban context where there are lots of homes together. So the question that you asked about whether I can connect you to the person who's managing that if you are interested as a developer. and you can explore that with them in terms of how best to do that.
Sir, Government of India is constructing approximately 10 to 20 million homes in rural and semi-urban areas.
Yeah.
So there are large plots available for those. So we can install solar panels on those affordable houses.
Yeah.
And with this technology, we can share that amount with those poor peoples also,
Absolutely.
using their roof.
So drop me a note, email, or catch me afterwards, and I'll give you the contact. Which utility is involved in India? There is a utility involved in India who is already trying to test that.
Thank you, sir.
Many thanks. Dharan.
Thank you, Director General Dr. Ajay Mathur and Professor Prasad for that excellent speech. GRIHA Council has recently launched Paryavaran Rakshak, an innovative initiative intended to sensitize and educate residents of Resident Welfare Associations, or RWAs, on minimizing resource wastage and optimizing natural resource consumption. We are pleased to announce that we have so far conducted 2 such events, and more are there in the pipeline. As a part of this summit, we also had announced a contest, Are You a Paryavaran Rakshak, or an environmental warrior, on social media, to know the stories, your stories, for protecting the environment. There were quite a few stories that were submitted to us, and out of which we've selected 5 of them. We have 3 of our winners here. I would like to invite them, and I would also like to invite Dr. Mathur and Professor Prasad to kindly give away the hampers. Can we have Mr. Srijan Mathur, please? Mr. Srijan is a part of Tree Take Responsibility for Earth and Environment, which is a group of ladies and few kids from Noida who have successfully banned the usage of plastic bags in local weekly market without any official authority. Now they have been able to reduce 99% reduction of plastic bags. Next, I would like to invite Vihan and Nav Agarwal on stage, please. There are 14 and 11-year-old brothers who help in reducing the waste sent to landfills. They operate in South Delhi. In a few months, their NGO One Step Greener has managed to get over 200 households involved in Vasant Vihar, Shanti Niketan, Westin and Anand Niketan, and taught us how to segregate dry waste and sell to an organized player. Now can I have Arisha Chaturvedi on stage, please? You have to get another. Arisha took a small step on a trip to Ladakh. Tourists had mercilessly thrown plastic bottles and wrappers at random places across the otherwise untouched places, as if they wanted to leave their footprint in the form of litter. She made sure such images are clicked of such places and picked those trash to throw it in the dustbin. Small efforts like these help sensitize the people around. There are 2 other winners who unfortunately could not be with us. Mr. Lomas Dongel, who is a school teacher from a place called Makha in east of Sikkim. He founded a small initiative called Hariyo Makha, Sikkim Against Pollution 2015. And we also have had selected Jitendra Shinde, who works with the foundation on Hanuman Tekadi as a volunteer, where they start sapling preparations from seed balls in 2017, the rainy seasons. Also, we would also like to take this opportunity to felicitate our GRIHA patrons. The GRIHA patrons are proactive members of GRIHA family who have been instrumental in adoption of GRIHA in various parts of the country. I would now like to request Mr. Adil from GEED India to kindly come up and collect this certificate of appreciation from GRIHA Council. Thank you. May I now request Professor Chitralekha Kabre of DCRUST, Department of Architecture, Deenbandhu Choturam University of Science and Technology, to please come up on stage and collect the certificate. I now request Mr. Ashish Sachdeva from Green Dream Foundation to kindly come up on stage and collect the certificate. GRIHA has also been able to identify British School as one of our green patrons. I would now request Dr. Mathur to kindly present a small token of appreciation to Professor Deo Prasad. Thank you, everyone. May I now request everyone to proceed for a short break to hub area where tea and coffee shall be served. After the tea, we have 4 parallel tracks. The venue for thematic track 13, user-centric design, bane or boon, is in Juniper Hall. Thematic track 14, water stress, perplexing possibility, is in Jacaranda. Thematic track 15, health and well-being in urban environment, is at Tamarind. And thematic track 16, market and legal perspective, is in Amaltas. I request you all to be present at the respective venues at 15:45 sharp for these interesting and thought-provoking sessions. Thank you.